Hello students, today we are going to start a new lecture series on differential calculus. This is lecture number 1 of the series. So we start with a new topic, that is limit. So let us start the definition of limit, epsilon delta definition of limit. So this is symbol epsilon. This symbol is known as delta. We call this delta. So epsilon delta definition of limit. A function f is said to have a limit L as x tends to a, to a point A, written as, so when we say a function f has a limit L as x goes to a, as x tends to a, so how can we write this? We write this written as limit x goes to a f of x, that is equal to L. So a function f is said to have a limit L as x tends to a if and only if given epsilon greater than 0. So we take epsilon to be however small, there exists delta, a positive real number. Delta be any real number, but we take positive real number. So delta to be greater than 0, delta greater than 0, and this delta depends upon epsilon. So delta depends upon epsilon. So we write a symbol delta epsilon in bracket. The meaning of this symbol is delta depend upon epsilon, such that mod fx minus L is less than epsilon. That is, distance between fx and L should be less than epsilon, and we choose epsilon to be as small as possible, right? So it is the estimate fx and L. So when mod of fx minus L is less than epsilon for mod x minus a to be greater than 0, less than delta. It means x is not equal to a. That is, x is not equal to, because if x equal to a, then it is 0. So 0 greater than 0 is not possible. So we are taking the deleted neighborhood of point A. Or we can write this as, by the definition of modulus, we can write this as minus epsilon is less than fx minus L is less than epsilon for minus delta is less than x minus a is less than delta. X is not equal to, and L minus epsilon or is less than fx is less than L plus epsilon for a minus delta less than x less than a plus delta for x is not equal to. So what is the meaning of this? So let us think about, we draw the graph. So if we take x-axis, this is x-axis, this is y-axis. So if I take a function f to be, this is the function fx. So let a be any point on the x-axis corresponding to this point a, we get f of x, f of a. And now we take the delta neighborhood around point A. So this is a delta neighborhood, that is A minus delta. This point is A plus delta. The distance between this and this distance is delta, and this distance is also delta. So now if I take this to be my limit, right? If I take f of a to be L, as x goes to a, f of a x to be L. Right? So we take epsilon neighborhood around this point. So this is L plus epsilon, this is L minus epsilon. So this is the interval. Now if I take x to be here, if I take the left hand limit, right? Left hand limit means when we take any point to the left of a, if my x lies here, then according to this, the function lies in this interval. That is L minus epsilon to L between L, right? So fx lies here, L minus epsilon to L, greater than L minus epsilon and less than L. So if I take x to be here, then this goes, fx goes towards L. Distance between fx and L is less than epsilon. So as x goes to a, so fx goes towards L. So from left hand limit, left hand side, as x goes toward a, then fx goes to L. Similarly, if I take x to be here to the right hand side, right? Then my fx lies, so fx is here. If I take x here and fx comes closer to L. So as x goes to a, as x comes closer to a, what is my fx? Fx come closer to L. So from both sides, left hand side as well as right hand side, as x goes to a, fx goes to L. It means we can say fx has a limit. So we can write limit x goes to a, f of x, that is equal to. It means, what is the meaning of this? That the left hand limit and right hand limit of this function at point A exist and both are equal. It, or we can say limit x goes to a negative f of x and limit x goes to a positive f of x, both exist and are equal. And in term of epsilon delta definition, we can write uh, mod x minus a. You can take x, if I take x to be here, then x and distance between x and a to be less than delta, because this whole distance is delta. So x minus a is less than delta. So we can either you can take point here. So we can say mod x minus a less than delta, and because x is not equal to a, so it must be greater than 0. What is my fx? Fx minus L, mod fx minus L is less than 0. Okay? So this is the epsilon delta definition for the limit. Now, in this case, existence of f of a is not necessary, right? For limit x goes to a fx, limit x goes to a negative fx or limit x goes to a positive fx to exist, then existence of f of a is not necessary. F of a exists kar raha hai, that is not the necessary condition. Now, an article that is proof that limit x goes to a f of x exists if and only if limit x goes to a negative fx and limit x goes to a positive fx exist and are equal and are equal. Limit x goes to a exists means if and only if means p implies q. If my statement is if p implies p if and only if q means p if p then q and if q then p. So limit exists means left hand limit, right hand limit both exist and are equal. If left hand limit and right hand limit both exist and are equal, it means limit of the function at point A is exists. Right? Okay. So we have to prove this. So P if and only if Q. If this is my statement, meaning of this is if P then Q, this is one condition, and if Q then P. So first we have to prove that P implies Q, and second we have to prove that Q implies P. So this is the meaning of P if and only if Q. So P, what is P here? So this is my P. What is Q? This whole statement is Q. So we have to prove according to this. So if P, so let us start with that given that limit of x goes to a fx exists. So if limit x goes to a f of x exists, so if limit exists, then it is equal to some real number. So let limit x goes to a f of x to be some number, real number, let it be n. So given any epsilon greater than 0, however small, even you can fix this epsilon, right? There exists delta greater than 0 and this delta depend upon epsilon. Delta greater than 0 such that this we write with, because it is given that limit x goes to fx exists. और हमने अभी पढ़ा if limit x goes to a f of x exists, then we can write then by epsilon delta definition, given any epsilon greater than 0, there exists a positive real number delta such that mod fx minus l less than epsilon for mod x minus a greater than 0 less than delta. So we can use this. So we can write this that mod fx minus l is less than epsilon for 0 less than mod x minus a less than delta. Okay. So this implies mod fx minus l is less than epsilon for If I open this, we get x lies between a minus delta to a plus delta, but x is not equal to a. We have already discussed this. Right? This x lies between my a minus delta to a plus delta, and here in you can also see this x lies between. You can take x here, then x lies between a minus delta to a plus delta. If you take x to be here, then x lies between, means whatever x you can take within this interval, x lies between a minus delta to a plus delta. So from if limit exists, so whether you take x, whether you take your x to be here, if I take x to be here, or if I take x to be here, right, then x a minus delta to a, this is my point a minus delta to a, distance between fx and L to be L is, that is less than epsilon. If I take x, my x to be here, that is a, that point a, x lies between a and a plus delta. Again, this point gives fx to be here. It means again fx and distance between fx and L, that is less than epsilon. So whether we take from point x to be the left of a, again it's satisfied that mod fx minus L is less than epsilon. If I take the point to be the right of point A, then again it's epsilon. So we can separate this. This implies fx minus L is less than epsilon for x lies between a minus delta to a, and and mod fx minus L is less than epsilon for x lies between a to a plus delta. If it is not clear, then think about this. We have already discussed about this graphically. Visualize a graph, think about this, and then we proceed. So it means left hand limit exists as well as right hand limit exists. So this implies limit x goes to a negative f of x, and a negative means you take, this is my interval, this is my a, this is a minus delta, this is a plus delta. So if I take my x to be here, then this x goes towards a, right? So from left hand side we get the value L, function goes towards the point L. If I take x to be here, then again function gives the same value. So limit x goes to a negative fx and limit x goes to a positive fx exist and are equal, and are equal. That is limit x goes to a negative fx is equal to limit x goes to a positive fx. So first part is over. Right? Now we start with limit x goes to f of x exists, and we prove that left hand limit and right hand limit at point A exist and are equal. Now conversely, we start with that left hand limit and right hand limit both exist and are equal. This is given. Now what we have to prove, that limit at that point exists and equal to L. So if limit x goes to a negative f of x, limit x goes to a positive f of x exist and are equal. Equal. Equal means that is limit x goes to a negative fx is equal to limit x goes to a positive f of both limit exists and are equal. So now we have to prove that limit fx minus L is less than epsilon. So what we have to do? We have to show that this is our goal. We have to show that limit x goes to a, f of x is equal to L. And by epsilon delta definition, we have to show that we have to estimate fx and L to be that is less than epsilon for mod x minus a greater than 0 less than delta. So we have to prove this part. How can we prove this? So we use this condition. This is the given condition. So given epsilon greater than 0, so let epsilon greater than 0 however small, even it is already fixed, right? So it is already fixed. So we take given epsilon greater than 0. So epsilon greater than 0, corresponding to that epsilon, there exists delta 1 greater than 0 and delta 2. We get two real number, positive real number, delta 1, delta 2, such that both delta 1, delta 2 depend upon epsilon, such that mod of f of x minus L is less than epsilon for a minus delta 1 less than x less than a. So let this be my first equation. And for right hand limit, f of x minus L is less than epsilon for a less than x less than a plus delta 2. So these are two equations. For left hand limit, we get some positive real number delta 1, and for right hand limit we get some. So if this is my point A, for left hand limit, if I take this distance to be a delta 1, so this is my a minus delta 1, and if I take this to be delta 2, then this point is a plus delta 2, right? Or the next other possibility is, if my point A is, then this is my a plus delta 2, this distance is delta 2, and this point may be delta a minus delta 1, this distance is delta 1. So I don't know whether delta 1 is greater or delta 2 is greater. Still, we don't know. But we find two positive real number, delta 1, delta 2, that depend upon epsilon, such that left hand limit fx minus L less than epsilon. We estimate fx and L to when we goes towards A from left hand side, we find delta 1, and from right hand side we get delta 2. So now what we do, we choose one number. If I take, because we don't know whether delta 1 is greater or delta 2 is greater, so we choose delta minimum of delta 1 and delta 2, whichever is minimum. If this case, this is my first case, right? If this happen, then my delta 2 be, this is my delta 1, so I choose this delta 1, right? So my delta, this is my, I choose delta 1 to be delta. So this is my a minus delta and a plus delta, right? If this happen, then delta 1 and delta 2 is minimum, so I take delta to be delta 2, and this is my interval a minus delta, and this is a plus delta, because delta 2 equal to delta. So this is my D. So what I do, we choose whichever is minimum, whether delta 1 is minimum or delta 2 is minimum, right? So then mod fx minus L is less than epsilon for a minus delta 1 less than x less than a, and mod fx minus L is less than epsilon for a less than x less than a plus delta. So when we combine this implies mod fx minus L less than epsilon for 0 less than mod x minus a less than delta x is not equal to. Now we prove that this implies by definition of epsilon delta definition of limit, we can say limit x goes to a f of x is equal to henceforth. Pause, revise, and then proceed. So you take a pause of 30 seconds. If you understand this, then we quickly revise this. After revising, then you proceed. So next result is prove that limit x goes to a f of x if exists is unique. So we have to prove that if the function has a limit, if function limit of the function exists, then it is unique. So if it is not unique, then what happens? It may have more than one limit, right? So we start with if function has a limit, then what is the meaning of this? That mod fx minus L is less than epsilon for mod x minus a greater than 0 less than delta. Delta depend upon epsilon, or limit x goes to a f of x equal to L, where L is any real number. So now, and if function has limit, if its limit exists, then it is unique. So if possible, its limit exists, but it is not unique. So if possible, let f of x has, let limit x goes to a f of x is equal to L, and limit x goes to a f of x is equal to L dash, right? So it has two limits. So we take the case if function has function limit of the function exists, but it is not unique. Not unique means it is more than one. So more than one means let it be two. So it has two, three, and so on. So let it be two. So we take L and L dash with the two limit of the function fx at point A. So given any epsilon greater than 0, however small, there exists delta 1 greater than 0, delta 2 greater than 0. Why delta 1, delta 2? Because function has two limits. So the same delta, maybe same delta will work, or maybe it is different, right? So we take delta 1 and delta 1, delta 2 with two positive real number, both depend upon epsilon, such that mod fx minus L to be less than epsilon by 2 for mod x minus a greater than 0 less than delta 1, and mod fx minus L dash is also less than epsilon by 2, but here delta is delta 2. Mod x minus a greater than 0 less than delta 2. Again what we do, because we have two delta 1 and delta 2. So we try to minimize this, right? So what we do, we choose the minimum of delta 1 and delta 2. So we choose a delta that is minimum of delta 1 and delta 2. So if I choose delta to be minimum of delta 1 delta 2, then from above two conditions we get f of x minus L to be less than epsilon by 2 for 0 less than mod x minus a less than delta, and mod fx minus L is less than L dash is less than epsilon by 2 for x minus a less than delta. Now we have to estimate this point L and L dash, right? Because we have to prove that both are equal. If limit is a unique, then it means L and L dash both, they are not distinct, but they are equal, they are same. So what we do, we take the distance, we estimate L and L dash. Estimation means we take the modulus of the difference of 2 point L minus L and L dash, that is L minus L dash. So we use curry leaf concept. What we do, we add fx and we write this fx minus fx plus L minus L dash. So we add fx and subtract fx. This concept is called curry leaf concept. We add something, we use that concept. So we can also write this as fx minus L dash plus or minus fx minus L. And we know that this is less than equal to mod of fx minus L dash plus mod of fx minus L. Right? Because we know that mod of a minus b, a plus b, that is less than equal to mod a plus mod b. And we can also write mod a minus b as mod of a plus minus b. So that is less than equal to mod a plus mod minus b, and mod minus b is b, mod b. So mod a plus mod b. So, and this mod fx minus L is less than epsilon by 2 when x come closer to the point A. X lies between a minus delta and a plus delta. Only if x lies between this interval, then only we can write this. So we use this. This is less than epsilon by 2. This is less than epsilon by 2. But for 0 less than mod x minus a less than delta. If x lies between this, then only we can use this. And that is equal to epsilon for 0 less than mod x minus a less than delta. So if we get L minus L dash is less than epsilon, then because epsilon is arbitrary small positive number, so we get L minus L dash to be that is equal to 0. Or we can say that we can also use one more concept. A and B be any two real number. Given any A, B in R, we can say A equal to B. Two real numbers are equal if mod A minus B is less than epsilon. Here epsilon is greater than 0. Right? So if we prove this, then we can also say that both number are equal. So if mod L minus L dash is less than epsilon, then you can give this argument. So we directly write that L is equal to L dash. Otherwise, but you can do, because dc less than epsilon and epsilon is any arbitrary positive real number. So we can take this is only possible if I take L minus L dash modulus of this is equal to 0 and L minus L dash equal to 0. This implies that L equal to. So both L and L dash are not distinct, but they are equal. Okay? So if limit exists, limit of a function at a point exists, then it is unique. So now the next article is, if limit x goes to a, f of x is equal to L, then f is bounded in some deleted neighborhood of a. So first we define what is bounded, right? Before proving this article, give one definition how we can define a function to be bounded. A function, or we define something. Let f is a function from R to R, real number to real. Then f is said to be bounded if there exists a positive real number, that is m greater than 0, such that mod of fx, such that given any x belongs to R, you give me any, such that mod of fx is less than mod of fx is less than. So then we say that fx is bounded. So mod fx is less than epsilon means fx lies between, if we open the modulus, fx lies between minus m to m. So if this is my real number, m is any real number, right? So minus m to m, all fx lies within this interval. All fx, you can take any x from R, your f of x lies within, fx lies here for all x belongs to R. So if this happens, then we can say that function is bounded function, right? So we use this definition to prove the above theorem, right? So so let so what is given? Given f of x, limit x goes to a, f of x is equal to L. This is given to us, right? So if limit of function is given, then we can use the epsilon delta definition. What is that? Given any epsilon greater than 0, however small, there exists delta greater than 0, this delta depends upon epsilon such that mod fx minus L is less than epsilon for 0 less than mod x minus A less than delta. So this is by definition because it is given. Limit of function is given, so we use the epsilon delta definition. Okay. So now what we have to do? Because we know that if function is bounded. When we say function is bounded, so this is right. Uh, when we say function is bounded, if mod of fx minus L is less, mod of fx is less than some positive real number n. So what we do, we have to estimate mod fx. So now mod fx, we have to find what is this fx, modulus of fx. It must be less than to some positive real number. So again, we use curly leaf concept. What we do, we add some number and subtract some number. Again, we can write this in term in bracket. We can make the pair. This is less than equal to mod fx minus L plus mod L. We use mod A plus B less than equal to mod A plus mod B, and this is less than epsilon plus mod L. Because epsilon greater than 0, this is positive number, and mod always gives us a positive number or non-negative number. If L is 0, then mod of L equal to 0, but 0 plus epsilon is greater than 0. This whole term gives us a positive real number. So let it be equal to some number L. So this implies mod of fx is less than m for any x, for any x that lies between, for x lies between minus a to minus a minus delta to a plus delta. Right? So it means in the deleted neighborhood, the function is bounded. So hence f is bounded in a deleted neighborhood of a. Deleted neighborhood of a means we are not taking the point a. So this point is not a part of this. So a minus delta to a plus delta. You can take any x except this a. So we have discussed 3 theorems in this lecture. So we have discussed 3 theorems in this lecture. Uh, so what is the converse of this theorem? What is the converse of this theorem? So note, converse of this theorem need not be true. Right? Converse of article 3 is not true. But what is the converse of this theorem? If function is bounded in deleted neighborhood, then limit at that point may not exist. If function f is bounded in a deleted neighborhood of a, then limit x goes to a, f of x may not exist. May not exist. Now, assignment to all of you. You have to prove these two results. This is Article 4. What is this? If limit x goes to a, f of x is equal to 0. If a function has a limit 0 at a point as x goes to at a point a, and we have another function g, and g is bounded. So what is the definition of bounded? Bounded means mod of gx is less than equal to some positive real, less than equal to n. For every x in x belongs to the domain. X belongs to, if we take domain to be real number, every x belongs to a, mod of gx is less than equal to. If we take deleted neighborhood, then every point, you can take every point in that deleted neighborhood, mod of gx gives you is always less than equal to some positive real number. So g is bounded in a deleted neighborhood of a. Then what is the limit of the product of fx and gx? Then limit x goes to a, fx into gx, that is equal to 0. Next article is, if limit x goes to a, f of x exists finitely, then for any epsilon greater than 0, there exists delta greater than 0, such that mod fx1 minus fx2 is less than epsilon. You can take x1, x2 be any point within the interval in the deleted neighborhood. Then mod fx1 minus fx2 is less than epsilon for 0 less than mod x1 minus a less than delta, and 0 less than mod x2 minus a less than delta. X1 and x2 be any 2 point within the delta neighborhood of point. So you try to prove these article number 4 and 5. In next video lecture, we will discuss about algebra of limits and some examples related to article number 4 and article 5. Thank you. Have a nice day.